In this video, we'll study the shape and orientation of d orbitals. We'll use the x, y and z coordinates as shown. And we will take a particular case of 3D xy because we have learned that while solving Schrödinger wave equation, both radial and angular parts must be considered. The node in 3D xy is x equal to 0 and y equal to 0, which is the yz plane and xz plane, which are angular nodes. So these are nodal plane for dxy, actually 3dxy orbital. Probability of electron being here, that is on the nodal plane, will be 0. So where will the electron be? Allow me to make an attempt to represent it by clouds. And the answer is almost everywhere else. This cloud represents the possibility of electron being at a specific position. Higher the density of the cloud, higher the possibility. I'll remind you once again that the probability is something which we cannot see. This is the best approach to depict the situation. So, while the electron appears to be everywhere, there is a pattern. As we move away from the nucleus, probability keep on decreasing as dictated by the radial wave function. 0 being the number of radial node in 3D xy. As we get closer to nucleus, the likelihood increases. Now let's take a look at what's going on at the nodes, our nodal planes. And we can see the probability of electron existing at x equal to 0 and y equal to 0 is 0. Now if we want to represent a complete picture of where an electron is in terms of probability, we will need the entire picture till infinity. But that is not necessary. Merely the region containing 90% of the likelihood will suffice. And for the 3D xy orbital, the result is as follows. So there we have it, the double dumbbell shape of d orbitals. And since the angular wave function is independent of the principal quantum number, 4dxy, 5dxy and so on will have similar probability distribution for the angular part of the wave function. So this was dxy, the dyz orbital, dzx, dx square minus y square are explained similarly, with the exception that their nodal planes are different. We will deal with the dz square separately. Check out the orbital shape and orientation of dyz, dxz, dx square minus y square and dz square on our channel, as well as our lecture in Hindi for an in-depth explanation. Bye and take care.